In this video, you will learn how Amesim differs from block diagram models and how it uses bond graph theory. A simulation model in Simcenter Amesim consists of assembling components that represent a part of the system being modeled. The approach looks similar to block diagram modeling, where a model is built with mathematical blocks. However, in Simcenter Amesim, the components represent physical blocks with full equations included within them. This allows for a more comprehensive representation of the modeled system. In that sense, the information exchange between components is physical information, whereas, for the block diagram approach, the information exchanged is unitless. Additionally, in order to have a full physical state of the system, Simcenter Amesim deals with multiple information exchanges between the components. When the system includes advanced physics equations, or if it gets bigger, the block diagram approach requires a significantly higher level of complexity in building the equivalent system. For derivative equations, feedback loops are required, which is not the case with the physical approach. Also, a single component can deal with different domains since it contains all the necessary equations to evaluate its physical state. Let's have a better understanding of the exchanged information between Simcenter Amesim components. Simcenter Amesim is based on the bond graph theory, which is a graphical representation of physical systems with bidirectional exchange of physical energy, unlike block diagrams and signal flow graphs with unidirectional flow of information. In the system below, you can see the different physics involved in the energy exchange. The battery provides electrical power, which is converted to mechanical rotational energy. This translates into torque and angular velocity information exchange. This information is then used as input for a hydraulic pump that converts mechanical energy into hydraulic energy with flow and pressure. With physical modeling in Simcenter Amesim, we can monitor the energy flow in the system and observe its dynamics or transient behavior. To be more specific, the energy is computed from the power, which is calculated from effort and flux in the different domains involved. Effort and flux can be retrieved in all physical domains. For example, in mechanics, the effort is force, usually in newtons, or torque in newton meters in the standard unit system, and the flux is velocity. In hydraulics, the effort is pressure and the flux is the flow rate. In thermal, the effort is temperature and the flux is heat flow rate. In electrics, the effort is potential and the flux is current. The possibility to connect two components together is defined by the compatibility of the exchanged information. This is called causality. We will come back to this concept when we learn about how to build a system. This concludes the video on how Simcenter Amesim works.